Okay, so the I've had a couple of emails about honors contracts. And so just as a reminder, if you're interested in an honors contract, if you go into the course information module on Canvas and scroll down a little bit, there's an honors contract information and submissions kind of like pseudo assignment. If you click on that, it talks about honors assignments for the course and gives some examples of projects. And I've thrown a few more examples up there. So go ahead, and if you're interested in the honors contracts, take a look at that and kind of decide, do some of those sound like a variation on one of those? Is something you'd be interested in doing? And if you're interested in that, then contact me and we can go through the sign-off process on the honors contract. And just to give you an idea, a usual deliverable for these honors contracts, I really like the idea of producing kind of like teaching aids. And so, you know, a short video demonstrating a particular concept or a short report, usually one, not necessarily both. Those are good things, but there are other options as well. So you can take a look at that if you're interested. Just wanted to throw that out there because I've gotten some emails about that. All right. There's a question. It's an honors contract. If an honors contract is not completed, it doesn't have any effect on your grade, at least in this course. And so the honors contract is viewed as sort of separately motivated by the course, and it would give you credit towards, you know, Barrett and your honors progress. But if you end up not doing it, then at least there's no cost in terms of your grade for this course. It just goes on as a not complete honors contract, but your grade for this course will just be your work in this course. Okay. All right, so we read this paper, Applying System Archetypes. This is one of the, I think it's the only official or required reading that I've given that is not from the Moorcroft textbook. I like this paper because it's, you know, written in a very different style than Moorcroft, and I think it connects to a larger set of these system archetypes that are understood across the systems thinking community. So one of those you know, archetypes that you see showing up there, there's an example of it that's kind of being depicted here. So this is an example that I'm sure we've all been in once, you know, once in our lives, where we go onto the freeway at rush hour and it's packed. And so you look around the freeway at rush hour and you say, if these idiots would have just taken the bus, I could be home by now. So it's this interesting case where you entered the freeway and you're frustrated that everyone else entered the freeway, because if they would have just gotten out of the way, then you would have been able to benefited from the freeway's high speed. But because they are doing exactly the same thing that was individually rational for you to do, then they end up taking away from the benefits that you receive and that they receive. And in the end, you all end up being stuck in so much traffic that you don't get home faster than you would if you would have just taken side streets. In fact, it might even be slower than side streets. So, oh, I'm sorry about the notepad there. Thank you for pointing that out. So just so you know, so I'm presenting on two screens and I'm looking at my kind of presenter view, which is like this large dashboard, questions and other things that's there. And so I often forget that I've got the other screen, which is kind of just out of vision. So I apologize for that. So I don't think on the previous slide there was anything that exciting other than the title slide. So, all right, so this is kind of the description of that there. What can somebody tell me, what archetype do we usually associate with this type of problem, where doing the thing that's individually best ends up doing the thing that is globally worst? What's the type of problem with that? So I'll let you, a couple of people maybe put some votes in the chat. I see one in there. Something I'm sure you've heard about in some of your other courses, those of you in sustainability for sure. And one of the archetypes from the reading. So any other thoughts on what we might be looking at here? Something that's individually best, but globally worst. All right. So I see a couple of other votes here. So what I'm sort of looking for here, which I think has been kind of mentioned here, is describing a generic a generic issue with so-called open access resources or common pool resources. I don't want to go into the distinction of, is open access equivalent to common pool? They're technically, there might be a sort of a slight difference in how you use these two words, but for the most part, you can think of them as being synonymous. The synonymous is that an open access resource is a resource that most common pool resources are going to have open access problems. And an open access resource is a resource like a freeway that is non-excludable. Anybody can get on the freeway and is rivalrous. For everyone who gets on the freeway, they are going to take away from everyone else on the freeway. And there are a lot of other resources that are like this. There are, for example, overgrazing and overfishing. So if you go into a fishery, if it's an open access fishery, then anyone can fish in that fishery, but everyone who fishes in the fishery takes away from the limited supply of fish. So the next person to join the fishery, even though they experience more fish than they did before they got there, they take away from the fish that other people are experiencing there. So this is a very generic property. Whenever you have these two properties, you set up the tragedy of the commons, and that's what I was looking for there. So it's a tragedy because we can't really blame the individual in this case. The individual really is doing what's best. They were hungry, they could eat more if they went into the fishery. They needed to get home. The fastest way to get home was to take the freeway. How can you blame someone for taking the freeway? Now, in the end, you probably need a set of people to not take the freeway in order to maintain the freeway as a good resource. But who decides who's going to be taking the freeway and who's not going to be taking the freeway? That ends up sort of being the main issue there, is that without an institution that somehow helps break these symmetries, then we're just counting on everyone to sort of either altruistically decide that they're not going to do the thing that's best for them, which probably isn't going to happen, or you just deal with the fact that we're going to get overexploitation, which is going to effectively get rid of the resource that we all love to begin with. And so, like I said, a freeway is one example. There's a bunch of other examples here, and a lot of these non-renewable resources are this way, but even fisheries, which are technically renewable resources, can be this way. And all of these can be described by this archetype, this tragedy of the commons archetype that they talked about in the reading, where it was sort of defined by a common spine where you've got some total activity. So this is the total number of people making use of the freeway. And after some delay, then the gain that every individual receives for that will end up being decreased. So that's why there's an opposite here. So you increase activity, you decrease the gain. And then you end up having all of the parties that are contributing. They're kind of like fins radiating out from this spine. So in this case, we're only drawing two parties, party A and party B. And you can think of them like two groups of people. So like, two departments trying to use the copier, or you can think of them as two individuals. And this diagram is sort of just simplifying what it might look like for multiple individuals. So there might be a party C that's sort of sticking out into the plane, or different angles, like radiating out from the spine. So you can imagine that there's just like a huge number of individuals all rotating around this spine of total activity and gain per individual activity. So, and then for each individual, because there is some gain per individual activity, then there is going to be a reinforcing loop, which every individual, when they feel that gain, they're going to continue to do the activity, which is going to cause them to feel that gain. And there's going to be this reinforcing loop, which causes them to continue to do that activity. Or if these are individuals on a team, then more and more individuals on that team are going to join in on this activity for the team, which is going to increase the total activity, which takes away from their gain a little bit, but it takes away from everybody else's gain. And everybody else's gain takes away from their gain. So that's sort of the dilemma here, or the tragedy, is that locally, we really can't blame anyone for following this reinforcing loop, because globally, the balancing loop doesn't actually come from an individual's own actions. It comes from everyone else's actions. So everyone else is putting a cost on you, and you're putting a cost on everyone else, because we do not feel the cost we put on them. then we don't think about the cost. And we just have to deal with the costs they put on us because that's their choice to put that cost on us. And in the end, the copier becomes a terrible resource. You never can get your copies. The freeway becomes as slow as the side streets. The fishery becomes overfished and eventually extinct. So there are some questions here in the chat. So does the tragedy of the commons eventually place blame on others instead of providing a different solution and acting upon it? The problem with the tragedy of the commons is that what the tragedy of commons tells us is whether a particular resource we've set up is going to be feasible and sustainable over time. So if we say we put out there a resource that's finite, that has these diminishing returns, because there's that question out there, the law of diminishing returns. If there is a resource out there that has diminishing returns, so every time somebody uses it, less of the resource is available. If we also do not control the access to that resource, then we sort of are going to expect that the resource will become overexploited and effectively no better than the situation was before we introduced the resource. Tempe Town Lake, for example. Tempe Town Lake in Tempe, they stock with fish. Now, if you read, in order to fish in Tempe Town Lake, you have to have a license, and that license tells you how many fish you're able to take out of that fishery. If they didn't make it so that people had to have a license to fish in Tempe Town Lake, then there would never be any fish in Tempe Town Lake, and Tempe would have to just keep restocking the fish. Now, because they've limited how many fish each individual can take out, they can hopefully limit it to the point where the fish reproduction will be enough to keep the stock there sustainably without the city of Tempe keep dumping more fish into the lake. So that's kind of an example there where that if I want Tempe Town Lake's fish to be a resource available to the public, I either need to keep dumping fish into that resource and spending that money, which is kind of like an escalation, or if I want the resource to just take care of itself, I need to limit how much access is available to that resource. So the tragedy of the commons provides us a highlight of how we need to manage this resource to make sure it's sustainable. It's not about blame, but it's about practicality. And so there's a question, is this like the law of diminishing returns? The law of diminishing returns is certainly related. That usually when I say the law of diminishing returns, I'm usually saying like, how much am I? Like I have at least 2 balls on my desk that I can squeeze when I get nervous or anxious or whatever like that. And I don't have 50. So the law of diminishing returns kind of tells me that eventually once I get enough of these anxiety balls on my desk, it's enough. I don't go out and buy another one because I don't get any more benefit over the ones that I already have on my desk. But apparently 1 wasn't enough because I got 2. And so that, I actually got 3 and I just don't know where the other one is. I'm a little worried that Dexter's got it. So, but 3, oh, here's a third, few. So 3 is enough. I don't need a 4th. So that's the law of diminishing returns. What we're talking about is kind of imagining that at a population scale to the point where not only is the ball that I own taking away from the value I get from the next ball I might buy, but it's the ball that I own takes away from a ball that someone else could have owned. So it's really about, is it a finite resource? And that's why we use the term rivalrous in this particular case. The resource is rivalrous, which means that my use of the resource, I'm a rival with you. If I use the resource, you can't. And so that's why it goes beyond diminishing returns. It's about competition. We are in competition for a finite resource, and that's what sets up this tragedy for the commons. Would the prisoner's dilemma fit in this diagram anywhere, or is this something separate? So that's another question that came out of the chat. The prisoner's dilemma, and this was also brought up in the reading, and I tried to make some comments in the perusal reading along these lines. So you might have heard about the prisoner's dilemma. The prisoner's dilemma is certainly related to this, but the prisoner's dilemma is focusing on the individual level incentives of who decides when to enter the fishery. So if you set up the incentives correctly, then maybe someone sometimes decides not to go into the fishery. And so in the prisoner's dilemma, it's it's focusing on the individual decisions. The tragedy of the commons is focusing on what happens at the population level once we've set up those individual level decisions. So they're complementary. So we use certain aspects of game theory to study individuals and certain aspects of systems theory to study groups. All right, any other questions about this idea of the tragedy of the commons? And I hope what I was trying to paint a picture of is that whenever we identify that this tragedy might occur, we might hope that it takes care of itself, but it usually doesn't. Now, people like Eleanor Ostrom, who you've probably heard about in some of your other classes, studied small scale groups that managed to avoid the tragedy of the commons through cultural norms, for example. So the norms ended up kind of breaking symmetries naturally so that people would not always do kind of what selfishly sort of made sense. But it turns out that usually when you scale to very large populations, then the type of institutional emergence that you get at small scale usually doesn't happen. So at very large scale, and this is what's kind of mentioned here in the guidelines, you usually need some third party to come in and say, you get access today, you don't. You get access tomorrow, you don't, and so on. And that's why, like in Tippytown Lake, we license how many fish people can take out of the lake. And we also have to enforce that. So if we talk about COVID-19 vaccines, if over at the Cardinal Stadium right now, depending on when you go to get a vaccine, you might find that they're so busy that they actually don't check even your driver's license, let alone whether you're in an eligible class. And if you show up there and you've been waiting for an hour, and even if you didn't sign up for an appointment, they might not care, and they might sign you up right there on the spot. Now, that's an example where it is supposed to be an excludable resource. It's supposed to be something that is exclusive to a certain set of eligible people. But if word gets out that actually anybody can go and get a vaccine, then can you blame someone for trying to get a vaccine? Now, if vaccines were an infinite supply, then it wouldn't be rivalrous, and it'd be like turning on public radio. And you don't actually blame somebody for turning on public radio and not donating. But because it is a limited supply, at least in the short term, then it causes a problem. So even COVID vaccines set up a tragedy of the commons if you end up having locations which don't enforce the eligibility rules, because they effectively do not do like they did in Tippytown Lake with licensing of the fish. So we see this problem everywhere, and whenever we see this problem, it usually suggests that we need something like a governing body to help us break the symmetries, because you really can't blame people for acting on individual level incentives, because why would you not? The only reason you'd not is if you just altruistically decided that someone else can go ahead of you. And maybe sometimes you do that, but most people who decide that someone else can go ahead are doing it because they are counting on that someone's going to let them go ahead in the future. So in reality, it is about incentives. All right, so there's a question. Would B in this model represent the rest of society versus individual actions? So that's a good question. So up here, A's activity and B's activity. I am viewing this as A being in the copier dilemma, which they talked about in the text. A is one department and B is another department. Or you possibly can think of this as A is me getting a vaccine and B is you getting a vaccine. And then there's a C and a D and an E and an F that just looks like A, B, A and B that are wrapped around this kind of central spine, but just not drawn here for simplicity. So there's a bunch of different ways that you can view it, but basically you just have up top here, this is a party who is receiving benefit from the resource. And on the bottom, this is another party that is receiving benefit from the resource. And when things are drawn this way, the fact that the A group looks exactly like the B group kind of is what sets up the problem. And that problem that gets set up is there's no restriction for either one to access the resource. So they're both going to access the resource, and they're both going to deplete the resource for themselves and for others. And then there's, what's nice about this kind of diagram is it not only helps us spot these things through this kind of graphical depiction and through this text depiction here, it not only gives us guidelines on solutions, but it also gives us predictions. So this behavior over time plot gives us predictions on what's going to happen, is that A and B, their activity is going to increase over time, where meanwhile, the benefit that every individual A and B receives from the resource is going to decline over time and eventually collapse and go to zero. So you'll have everybody crowding in to get a resource which is almost worthless, but it's just slightly better than not having the resource, but it's effectively like not having the resource. The promise of it being how it was when no one was using it is what brought everyone in to use it. And now everyone's using it, it basically is worthless. And so that is a prediction of what's going to happen over time when you spot this. And so what I'm trying to point out here is that these systems archetypes provide us a framework on which we can plan out scenarios. And so I kind of drew the tragedy in a kind of a theater setup here. So when we notice this sort of setup here, rather than letting it play out in terms of COVID vaccines or whatever, we can kind of let it play out in our models. And then our models, just like watching a play or watching Romeo and Juliet, allow us to think through the behaviors over time and then suggest when we should then act based on interventions that seem to work in the model that hopefully will then work in real life. And that's kind of what this whole article was about, was the different ways that you could make use of these models to be informative in your scenario planning. All right, so any questions about the tragedy of the commons so far before we get more general and talk about the 4 different ways to use the models? Is it clear what we mean by the tragedy of the commons and how this archetype applies? Can you see a copier? Can you see a fishery? Can you see the COVID-19? I see a question. So what is the definition of a collective action problem? Great question. So I mentioned this here. This is a collective action problem. A collective action problem is a problem where the solution depends upon multiple people acting in concert together. So this, if you look at this first bullet for the tragedy of the commons, effective solutions for the tragedy of the commons never lie at the individual level. There are some problems that we can count on individuals, like over time, the feedbacks will line up so that individuals will just, the problem will kind of go away on its own. In a tragedy of the commons, a single individual can't solve the problem. And so in that case, we really need a whole population to change how they're acting. We really need for everyone to agree that only this 10% of the population gets the vaccine first, the 90% has to wait. And that usually requires a third party like the government to say, this 10% are the doctors, the people over 75, et cetera. And so that group of the population, we are going to provide special access to. And the 90% are just gonna have to trust us that they will eventually get their access. But for now, they have to hold off. And so that's what we mean by a collective action problem. It requires a population level solution, a collective action as its solution. All right, any other questions about that? All right. So that was one example. The tragedy of the commons is a great example that we can use to talk about lots of different specific problems that relate to sustainability. And we generally are trying to take all of these archetypes and view them as ways that we can enhance our thinking about lots of different problems. And so the chapter goes over these 4 different ways that we can do that, which we're going to kind of step through here. And they all seem very similar, but they each kind of provide a slightly different perspective and a slightly different approach to making use of these. So that first one, this structural pattern template, was the one that was associated with trying to lift your thinking from individual variables to patterns of loops. And so it's this idea that you are going to draw out all of the individual causal links that you can think of in a system. And then you're going to step back, and then you're going to look for loops. And then you're going to step even farther back, and then you're going to look for patterns of loops. And at that high perspective, you almost can't even see the individual links anymore. All you see are the patterns of loops. And those patterns of loops end up telling you that there's a potential problem. And so as an example of that, if you step back from a particular problem, then like, let's say this delivery goal here. So in the assignment that was assigned on Tuesday, due on Sunday, I asked you to come up with a drifting goals example. And in the drifting goals example, then this is an example where you've got a balancing loop that is basically, you've set a performance standard, and that balancing loop is constantly trying to meet that performance standard. But during the time at which you're under the performance standard, in another balancing loop, it ends up causing the performance standard to change over time. And so I use the example of like weight gain. Like, I would like to be 175 pounds. You know, that for me, I think that would be a great target weight. And in grad school, coming out of grad school, maybe I was 220 pounds. And so that, you know, I set this goal where I would like to be 170 pounds from my 220, and I start dieting or exercising or whatever. And so what I end up doing is kind of this, this down here, I am trying, this is me implementing my diet. Now, my diet or my exercise has a delay in it. So as I noticed that I'm shifting from 220 to 218 to 216 to 215, but it is taking, you know, a month to drop every 4 pounds or something like that, if I'm lucky. And so over time, I never quite reached the 170. And my head starts saying to me, you know what, 170 would be great. I know that that would be really healthy, but I bet 190 would be fine. My cholesterol will probably be in check and all that. I could probably be okay with 190. So there's a parallel process that the longer it takes me to reach my goal, then the more time I have for an additional balancing loop in my head for my mentality to shift my goal. And that's the so-called drifting goals here. So because I have the ability to change my goal, then that goal has the possibility of reducing my progress in what I actually want here. Now, how might this occur? Now, well, the irony is usually this problem occurs when a system is designed so that you give yourself the freedom to actually do better. So in my head, I think I'd like to hit 170, but wouldn't it be great if I could hit 160? Well, I am just going to see how it goes. And if things look like they're going well for me for 170, then I'll update my goal and then change it to 160. So I build in this loop up top here, which allows me to change my performance standard. But the problem with that is by making my performance standard flexible, what I've accidentally done is allowed my performance standard to change in the other direction as well. And so I can try to put some little notes on here as well. And so that idea here is that because I've given the ability for the performance standard to change, I've also brought in a new frailty in the system where now the performance standard can actually not only get better, but get worse. And if it gets worse, then my performance standard will end up giving me less and less pressure to meet my original performance goal. And that's the drifting goals here. So there's a question here, like, you know, I could say, you know, how would I draw out my weight example here? Then, you know, instead of delivery time, I could change this to my, you know, my personal weight. So I'll just say, you know, WEIGHT if I can manage to write that. And I know that based on the gap between my actual and desired weight, then that's going to change, you know, my amount of exercise. Or that might change, you know, the amount of food I eat or something like that. And based on that, after some delay, that's going to change my actual weight. So that again is going to be weight. And then, but over here, instead of delivery time standards, this becomes weight standards, relax my weight goals. And so if I have a pressure to relax my weight goals, which just comes from this large gap here, then my goal weight, so this would be my goal weight, might change over time. And so I might need to update some of the directions here, some of the O's and S's, the pluses and minuses on the links. But overall, regardless of how I change this thing, I still am going to get a balance and a balancing on both sides there. So the drifting goals is when you have a gap between the performance you want and the performance you're actually having in between, and two balancing goals and so on. So that is an example where once you draw out a system, if you notice you got these two balancing loops, then what structural pattern templates tells us is I have a template there. I know that, that is the drifting goals structural pattern here. Two balancing goals strive to close the gap between a goal and current reality. Aha. Well, I know that if I see that pattern, that may be a red flag. And that red flag tells me that although you've created a balancing loop that you thought was supposed to allow you to shoot for even higher targets or better targets over time if you're doing really well, the fact that you've made your performance goal flexible means that there's a chance that if you don't get close to your performance goal quick enough, then the same process that would accelerate your performance might actually decelerate it by moving your performance goal down. And so maybe you just need a fixed performance goal. So it's a way to spot those red flags. All right, so are there questions there about this idea about how we can look for these patterns that are over here, and each one of these patterns has an associated kind of red flag? So we draw out the system diagram and we look for patterns in our kind of dictionary of patterns. And then with each one of those, we can end up finding common problems that tell us that, well, maybe we need to re-engineer the system so that it doesn't have this problem. Does that make sense? Okay. All right, so that's one way to view these things. Another way to view these things is to view them as lenses. And Moorcroft, in I think chapter 1, used this term as well, very briefly, but he also used them to talk about dynamic theories as lenses. And the idea here is not that we're building up a causal diagram and looking for patterns. In this case, we're actually going to think, what if this lens actually existed in our system? Then what might that tell us about this system? So we're almost going to, what we're going to sort of think about is we're going to look at a behavior that is currently existing over time, and then we are going to use a lens to provide us a new perspective on that behavior. And so their example was the copier perspective here. So we have a single big commercial copier in a company that has multiple departments. And we notice that that copier is always being used, and copy jobs are taking longer and longer and longer, to the point where you can almost just print another copy at your printer rather than waiting for the copy job to be done. So it almost diminishes the copier to the point where it's not even a useful resource anymore. Now, when we hear that description, before we even draw out any causal loop diagrams, it reminds us of the tragedy of the commons. And so we then take the tragedy of the commons and we view it as a perspective into thinking about the copier. And we, by viewing it under the orange tragedy of the commons lens, it highlights that, aha, this is a non-excludable resource that's rivalrous. And because it is a non-excludable resource that's rivalrous, we're probably going to need a third party that controls access to the copier. Or in this case, it wasn't access to the copier, but access to the rush requests. And so the problem here was that departments had the option of rushing a job, but there was no cost to rushing a job. So every department would put a rush on every job. And that would make the rushing of the jobs basically the same as a normal job. So a third party needs to be able to reject the rushing jobs and say, actually, no, you can't rush this job. And so that would be a tragedy of the commons motivated solution, is to have a third party regulate how many rush jobs you can put on things, or regulate which rushes actually make it into the copier. An alternate perspective would be, or an alternate lens would be to the view of this under shifting the burden. So when you notice this particular problem, where the problem started out as not much of a problem, nobody was submitting rush jobs, and then over time, a lot of people submitted rush jobs, and the problem got worse and worse and worse, then you start realizing that maybe this rush job that we introduced was actually not an effective solution to a more fundamental problem. Like, why were people asking for rush jobs in the first place? And so people really wanted they were doing a lot of copying, and they just wanted tons of these copies that were out there. Well, maybe there was a more fundamental solution, like maybe people didn't need to be copying as much. So giving people the ability to do rush jobs just better facilitates them doing the copying that maybe they shouldn't have been doing in the first place. Maybe we should have gone to every department, and instead of saying, well, we've been noticing that a lot of people have been using the copier, and so we're going to implement a rush job policy so that those of you who really need the copier can get your copies quicker. Maybe what they should have done is said, we've been noticing a lot of people have been using the copier, so we need to reevaluate whether each department needs to use the copier as much as it's been doing, because right now at current levels, it's putting a strain on the copier's performance. And that is a very different way of solving the problem. So either we stick with our current solution and regulate who gets to use it, or we go back to the drawing board and say, is there a way we can reduce the use of the copier without introducing these rush jobs? Those are both valid solutions to this problem. One of them comes from looking at the problem as a tragedy of the commons. The other one comes from looking at the problem through this other archetype of shifting the burden. And the shifting the burden here, if you didn't get this, the archetype here, the symptomatic solution here are the rush jobs. And the problem symptoms are the delays coming out of the copier. Now, the rush jobs create a side effect of basically a bad mentality for copying. So there's no conservation. So people do not want to conserve. They just want to copy more, and that ends up taking away from the fundamental solution, which would be getting people to copy less. And so I'm kind of coming up with terrible variable names here in terms of CLDs, but I'm just trying to sort of identify the portions of the problem here, is that we have a fundamental problem, delay in the copier, which had a fundamental solution. People need to copy less, but instead we shifted the burden onto people or onto another group, and by saying we're going to allow you to continue to copy as much as you want. But those that really need to get their copies fast will be able to get these rush jobs. But introducing the rush jobs signals to the rest of the company that they can copy as much as they want. In fact, they can copy more. So it ends up creating the fundamental solution ends up being degraded by the symptomatic solution. And that's what we mean by shifting the burden. All right, so are there questions about this idea of applying either of these two different lenses on the copier problem? Does that make sense? Or eyeglasses is another way to look at it. There were questions in the perusal about, when you're building these models, how do you know if the model is correct? In these particular cases, again, it's not ever about whether a model is correct, but it's how useful the model is. These are two different models of dynamical behavior, shifting the burden and tragedy of the commons. And they both might be in play simultaneously, or they both at least give us, they're both informative. And so that's the kind of the idea here, is we're not looking for the right model, but we are looking for a model that tells us a informative and useful solution. Now, there are some comments in the chat. It's a lot of info to remember. I am not expecting you to memorize all of these archetypes that were in this, like all of these different eyeglasses here. In fact, if you look at sample midterms, there are sample midterms on Canvas. I actually give you a cheat sheet of all of these archetypes. Usually, I give you that cheat sheet along with the little diagrams of what each archetype kind of looks like. And so I am less interested in you remembering the difference, being able to draw out the difference between escalation and drifting goals. But what I am more interested in is if I were to show you escalation and drifting goals, you could then quickly point out the differences. Or if I gave you a list of these and then also a system where I haven't found the structural pattern template, you'd be able to identify the correct template that would fit in that system, given that I've given you the list of all of the fundamental dynamic, system archetypes that are out there. So it's not about memorizing all the archetypes. It's about learning the process of applying the archetypes. And then over time, you'll start to recognize certain archetypes, like S-shaped growth. That is one you probably should burn into your brain, S-shaped growth. Growth and underinvestment, that's one that maybe should make sense to you, but maybe you don't remember all of that up front. Okay. All right, any other questions about that? Does that make sense? Okay, great. All right, so the other two that this paper brought up was dynamic theory, which is a fun one, which kind of relates to what I'm saying about finding a model that's useful. And so they had this particular problem where they talked about, you go into a company, they're working on some old email system. That old email system is always an option to use. You introduce a new email system, and you need people to transition to the new email system to get all their email over into it and use it. You're eventually going to get rid of the old email system, but before you get rid of it, people got to transition. So you need a certain compliance rate before you can get rid of the old system. And management says the new system's wonderful. This is like the Blackboard to Canvas transition. So nobody asked instructors about whether we should shift from Blackboard to Canvas. Students, I think, generally like Canvas over Blackboard. Instructors generally hate Canvas over Blackboard. But nobody asked the instructors, but they gave us a little bit of time to transition, but it was kind of like, if you don't transition, you're going to lose all your classes. And so you just had to transition. And so that is one way that you solve the kind of this transition problem. But if you're in another situation, maybe you can't just force people to transition. Maybe you need them to sort of buy into it. And so you say, all right, well, we're just going to put the other solution out there and everybody's magically going to buy into it. But that doesn't always work, right? So we had in our assignment B2, we had this market share competition between VHS and Betamax. Now, we don't really use either one of these VCR technologies anymore today. Back when these came out, VHS won. I mean, it dominated over Betamax. And a lot of people argued that Betamax was the better technology for a number of different reasons. But VHS kind of got in the market and got more penetration earlier. And it was sort of impossible for Beta to catch up, because once you had enough people with VCRs that were made for VHS, how are you going to convince them to go and buy a whole new VCR when there's plenty of VHS tapes out there that are perfectly fine? And so this is an example of the success to the successful archetype. And so it's a basic template here where you have two reinforcing loops that have a central member that shows that as you get more success of A, you're going to get an even more, if there's the reinforcement is going to end up allocating more of the finite market share back to A. So in the case of our loops that you guys diagrammed out in whatever that was, assignment A2, this fraction down here, this market share, that right there was something that could only be between 0 and 1. And the more VHS tapes that were in the market, then the higher this fraction got to 1. And the higher this fraction got to 1, the slower the growth you'd get of the beta loop, and the faster the growth you get of the VHS loop. And there is a similar process in ecology referred to as competitive exclusion, where you can't have two species occupying the same niche. You just can't have it. the one species that is slightly better than the other species can get a toehold and can end up dominating by this process. And so you naturally get an exclusion out there. So when you happen to see something in ecology where it looks like two things are sharing the same niche, that's really interesting. And it requires you to jump into it and say, that doesn't match my dynamical theory. What's going on there? There must be something else going on there. So when you see a violation of competitive exclusion, that tells you it's time to build some more models, because that doesn't fit our understanding of science, and there must be something else cool going on there that we currently haven't accounted for. But beta versus VHS, it's predictable. It is success to the successful. The email problem, it's predictable. It's the success to the successful. So this is our email problem drawn in the success to successful template here, where we've got the usefulness of existing email creates a reinforcing pressure on the use of existing email. Now, if we could manage to get people using the new email system, they would recognize the usefulness, and it would end up reinforcing. But if we have a lot of people using the old system, there's no way we can get this loop over here started. So when we think about this as a core dynamic theory for how things are working, then it tells us that we need to intervene. The same way I was saying that if we find a niche that is co-occupied by two species in nature, it tells us we need a new theory, because our standard theory, which is this theory, is that that shouldn't happen. Well, that's the same idea, that if we want these two email systems to coexist, at least temporarily, and then the one that is not dominating to take over, we need a new theory. We need to implement new causal links that aren't already there. In the ecology example, if we've got coexistence, then those links are already there, and we got to figure out what those links are as scientists. In the design example, if we want them to coexist temporarily, then the other one to take over, we need to build those links. And so this dynamic theory up here tells us that if we could somehow figure out a way to implement either this link up here or this link down here, then we can get people shifting from the old email system into the new email system. Now, the system theorists, that's kind of, they wipe their hands from that and they say, implement those links. It takes the IT professional to figure out, well, how the heck am I going to implement those links? How am I going to make it so that the usefulness of the existing email system is going to make the usefulness of the new email system even better? So that would suggest that I need to build something into the new email system that somehow builds upon the usefulness of the existing email system. So the existing email system had calendar integration, and people loved that. Well, I need the calendar integration in the new system, and I somehow need it to be better, so that if you had your calendar integrated in the old system, it's going to be even better integration in the new system. Or the other way around here, if you're using the old system, then somehow that is going to have to feed forward into making the new system even more useful. So if you've got an archive of email in your old system that's terrible to search for in the old system, we can import all of your email into the new system, and it's much easier to search through in the new system. And so it's actually going to be better for you in the new system. By introducing either one or both of these links, you create a balancing loop that ends up shifting everyone toward using the new system, which hopefully can end up upsetting this core dynamic theory up here of the success to the successful. It'll break the success to the successful. So recognizing that we have the success to the successful tells us that we can, is a theory that allows us to generate a new theory of how to add links to break up the old behavior over time to give us the new behavior over time. And so that's what we're kind of shooting for, is how to find this new extended dynamic theory. Does that make sense? Are there questions about that, about what we mean by dynamic theories? They help us spot weird stuff like, wow, we've got two species that exist on the same niche. These two animals eat the exact same thing, and they don't eat anything else. How the heck didn't this one animal just dominate the other one? It should have outcompeted the other one, and yet they're coexisting. What's going on here? That tells us that we need to add something to success to successful to explain how the animals coexist, Or if we want coexistence, how do we modify the dynamic theory to get coexistence? All right, so there's a question here. I understand what needs to happen, but I don't understand what a dynamic theory is and how it fits in. So a dynamic theory is just a hypothesis on what's causing the behaviors over time. So we introduce a new email system, and over time, everybody sticks with the old email system. Why the heck would that happen? Well, success to the successful is a dynamic theory whose behavior over time matches what we'd expect. If everyone was doing one thing and you introduce a new thing, no one's going to do the new thing. So it's a theory that explains the dynamic behavior over time. And so you can view the dynamic theory as the graph itself, but what we're going to learn in the next unit, starting with next lecture, is how to turn these graphs into models that we can simulate. And that is what makes them dynamic. But for now, these are just patterns that will end up becoming those dynamic theories that we'll end up being able to implement next week. But starting for now, they're just patterns on what processes are involved. And there's a question: why can't you link the use of existing email and the link and use of new email? So there might be. I think that. So the question is, could I add? I think this link here, and put a same there or a plus. And that I have to think that through, but if there, I think in the scenario that they were talking about in the paper, then the idea here is that you need that people need to elect to use the use of new email, and this getting this link is not really that possible. But if you can make people think the new email is useful, then they themselves will become more comfortable with it and start using it. So the idea here is we only can add links that we can actually implement. And the thought here is that the best we can do to get people to choose to use the new email system is by amplifying the usefulness of the new email system. And then over time, they will then start increasing the use of the new email. So if you were to try to add this link in here, then that would somehow be a way that, like, you just forced somebody turns on their computer and then you've managed to uninstall their email client and reinstall your email client. So if they were using the old email client, they are now necessarily using your email client. And that's what we're trying to avoid. We're trying to get people to choose to use it. And so there's no way for us to directly implement this because there's no way to directly get people to go directly to use it. Our only path is to get people to choose to use it, which means we have to amplify the usefulness. And then once we amplify the usefulness, then they will then choose to start using it themselves. Does that make sense? So it's about what we can build. And so in theory, this link would be great to add. But in the case of the email system, there's no way to add that link in directly because people have to choose to use it. We can't force them to use it. And this link is almost forcing them. It's saying that if you're currently using it, then you are suddenly currently using the other one too. Okay, great. All right, so wrapping up here, the last one, which really fits well into next week, is the tools for predicting behavior. And so this is really taking advantage of our endogenous perspective, where the idea is that the behaviors that we experience over time, we are viewing as being a product of everything inside our model system and not being something that is reactive to something that arrives from outside the system. So if you just model a system, like in this case, product development here, as a reinforcing loop, then taking the endogenous perspective here would suggest that your growth is going to continue forever. And the only reason the growth would ever stop is if you got a shock to the system, like an asteroid hitting your company, like a virus, causing the economy to decline, et cetera, et cetera. Those are totally valid. But we are interested in sort of understanding, are there other reasons why our growth would slow down that are explained by things that are more predictable than an asteroid hitting your company? That's not very predictable. And so realistically, every time you have a growth process, there are things inside the system that are going to limit the growth. So as you have more products up here, you get more customer orders, which ideally, yeah, creates more revenue, and that creates more product development, which creates more products, and that allows your revenue to just keep growing. But those customer orders aren't free. You actually have to do something with those customer orders. And that means you're gonna have the people that take those customer orders. They're gonna have to, to actually build all of those things. You're gonna get a lot of organizational complexity that's going to increase inside the organization, which means that you're gonna have a management burden. So now you gotta manage all of this complexity. And as you're busy managing all of this complexity with a finite management capacity here, then that is going to reduce the number of new products that you can actually bring to market. So even though in theory you could keep growing and producing more and more products, it becomes so hard to introduce new products that your actual product growth stagnates because you're managing all the complexity. Again, going back to Canvas, Canvas is a platform that grew out of thinking about managing high school, effectively high school curriculum. Small classes, small numbers of students, only 400, 800, maybe 1,000 students at a time, and that sort of thing. Then you can sell it to colleges, and universities. And now you've got universities with hundreds of thousands of students like ASU, or even tens of thousands of students and hundreds of instructors using it. And so now you've got lots more customers, those customers have lots more demands. And now basically Canvas has stagnated. They don't add new features because they're too busy selling their product. And so that's an example where we can't expect the growth in Canvas's development to continue over time. Now, of course, when Canvas sells their product, they show all this growth, in the past, whatever, 15 years or something like that. It hasn't been 15 years. And they say, and look, we're going to add new features. But in the last 5 years, they haven't. So that's an example of, how they can pretend like the historical pattern is going to keep happening. But in reality, there's no way they can keep up with the growth that they had there, and their product's going to stagnate. And that's what happened with them. And that's what happens with a lot of them. And those of us who take their word that the growth is going to keep going are fools, right? So it's a natural pattern that we refer to as limits to success. And so it is a way for us to predict the behavior over time. When you spot a reinforcing loop next to a balancing loop, which is just S-shaped growth. So, this is one we've heard about in Moorcroft, but he called S-shaped growth. And that S-shaped growth pattern, when you have the reinforcing loop next to the balancing loop, tends to produce a performance which initially rises rapidly, even though efforts inside the company do not. And it eventually plateaus and maybe even declines, even though efforts inside the company continue to grow. And this is a very predictable pattern, which does not, like an asteroid didn't have to hit right here. Like if you just looked at that behavior over time, you said, what happened? Why did your growth start to decline? Was it COVID? In this case, no, there was no COVID in this model. The growth started to decline as a predictable consequence of the previous growth creating so much internal complexity that new growth couldn't be maintained. So these end up being tools for us to predict these non-trivial changes in behavior. So that's an example. Does that make sense? What I mean by predicting these behaviors over time? Okay. And so what's interesting about that is that, the same behaviors over time, like different archetypes give you different behaviors over time. And that's what makes them so powerful. Even archetypes that are superficially similar. So in the limits to success archetype, initially when you have low performance, that's when the reinforcing loop is the greatest. When you have high performance, that's when the balancing loop is the greatest. There is another one called fixes that fail, which kind of relates. It's another lens on which we can look at the highway example from Moorcroft, the highway construction example, and it flips the order of things. So in fixes that fail, when you have a small problem, you implement a quick fix with a balancing loop. So the balancing loop happens first. And when the balancing loop happens first, that creates a short-term fix, but that ends up creating, after delays, an increase in the problem. So there is a reinforcing loop that ends up happening second. So as the problem gets bigger, this reinforcing loop gets bigger. So in this case, it goes from balancing to reinforcing. In this case, it goes from reinforcing to balancing. And so in limits to success, you tend to get behaviors over time that look like this. Performance increases, but then it plateaus. Whereas in fixes that fail, just like the highway construction example, you actually end up getting a fix where that you think solves the problem, but ends up creating unending growth of the problem over time. So here, this is a story of how growth dies. Over here, this is a story of how growth begins. Here, the growth is good and it dies, and that's the thing that's interesting. Here, the growth is bad because the growth is actually a growth of a problem, a growth of an unintended consequence. So we get different predictions of different behaviors over time, even with subtle changes in how these loops interact. And that's kind of the beauty of this systems thinking, is once we get used to how these loops interact, then we can make different predictions about different behaviors over time that otherwise would be very difficult for us to predict without formalizing these models ahead of time. There's a question, there's a comment here, you see how the archetypes work to compare it to the current one. Yeah, I mean, so I think it's nice to put these two archetypes up together, because then by noticing the differences in the BOTs, goes back to dynamic theory, you can ask, why does this behavior over time look different than that behavior over time? Then you can go back to the archetypes and say, oh, I see now, this reinforcing loop is strong when performance is low, whereas this reinforcing loop is weak when the problem is small. So you can start then noticing the fundamental differences starting with the behavior over time. So that's another way you can use these. And I'm just sort of describing fixes that fail here. Other examples of that, we've talked a lot about the escalation behavior, where we've got two conflicting actions trying to regulate the same thing. And even though you have two balancing loops next to each other, then you end up getting what looks like escalating behavior out of the kind of the figure eight that combines those two. And the what appears superficially similar to that is the drifting goals. And so here you have two balancing loops, but they're not trying to regulate the same thing that's in conflict. In fact, they're both almost working together. This bottom balancing loop is making a corrective action that lowers the gap. And this top balancing loop is making a corrective action that lowers the gap in a different way. So because they're not in conflict about where they join, then they don't escalate. They end up actually creating a decaying behavior where your goal ends up decaying over time and your performance decays right along with it. So even though these are two balancing loops together, when we look at the nuance of how they're plugged in together, that little Lego connection of how you plug these two in together is the difference between an escalation behavior where they go out of hand, where they keep growing over time, and the drifting goals behavior where the performance declines over time. So just examples of superficially similar, where they're plug-in slightly different gives you different behaviors over time. All right, so are there questions about that? Does that make sense? All right, so these are just 4 different ways that I'm really trying to pitch to you as as different opportunities to make use of these causal loop diagrams and these fundamental modes of behavior, these system archetypes that show up in lots and lots and lots of systems. And so we can use them as structural pattern templates, which is a very common way to do it. You draw out all of your causal links, you step back, and you look for patterns. And those patterns kind of give you an idea of where potential problems might be. Or even without going through all the causal links, you can kind of look at the behaviors over time, or you can kind of look at properties of the system, and you can say, all right, what glasses fit me for this? And when I kind of look at the system through those different glasses, then that kind of tells me different things I could try. So, oh, this looks like a tragedy of the commons, or this looks like shifting the burden. So there are different possible solutions for those two things. They're both valid ways of looking at the problem, and I might try solutions from both. I need a place to start, and the two different lenses give me two different places to start, which makes me more powerful, because if one doesn't work, then I can try the other one. A dynamic theory. So this is a case that helps you explain things that otherwise seem difficult to explain and propose interventions. How could these two species be coexisting when they both eat the same food? Well, the dynamic theory tells me they shouldn't be coexisting, so that must mean there's a different dynamic theory at play, and I need to investigate whether certain links might be there that could explain their coexistence. Or if I've got a situation where the dynamic theory suggests that I'm not going to get coexistence, but I need coexistence, then it suggests where I can put in links, other causal links I can implement in my organization that hopefully encourage coexistence or sustainability. And then a tool for predicting behavior. So if I can see the internal structure, I can predict the behavior over time. And those predictions might be surprising to me. Next week, we're going to say that, okay, we already know how to predict. We already have this kind of dictionary of common behaviors over time. Let's build more complex diagrams and simulate them so we can figure out the behaviors over time when we don't already have an entry for them in the dictionary. And what we'll end up finding is that the composite behaviors over time are going to look like they've got elements of these archetypes behavior over time kind of mashed up together. And we'll be able to use the system archetypes to help explain to people what's going on. Like this initial rise was because we had an escalation, a growth over here, but eventually it rounded off because there were limits to that growth. And then it oscillated because of these delays that we found here. But eventually it collapsed because there was a balancing loop on the performance standard, and it eventually pulled the performance out, or et cetera, et cetera. So it allows us new ways to talk about systems and to break them up to make them more palatable to our stakeholders. So ultimately, what do we do with all of these sorts of things? Well, that kind of was a process they talked about at the end of this paper, is that once we've explained to our stakeholders what's going on, we want to then explain to our stakeholders what we're going to do about it. And so, how do we come up with that? Well, we come up with an intervention. We're going to add a causal link. We're going to break a causal link. We're going to reduce a delay just by looking at what's in front of us, say, looking at our dynamic theory. And then we say, now that we've made that change, we generate that kind of extended dynamic theory, and we can predict, like, I think if this is true, if I manage to do this, this is what should happen. People should start shifting to the new email system. Now, before we go and implement this in real life, maybe we do a computer simulation. We run an experiment to see if our predictions actually occur. If they do occur, it gives us an idea that we did the right thing. But if they don't occur, then maybe we need to go back to the drawing board and figure out where we got it wrong. And so these three steps, these are the steps of forming a hypothesis about how the system works, making a prediction based on that hypothesis, and then testing to see if our hypothesis was correct. And if it was not correct, reforming that hypothesis. And that is exactly the scientific method. We just apply it to sustainability problems, which is why we are sustainability scientists. So we're not necessarily trying to understand, the proximate mechanisms behind the innate immune system and how it regulates your temperature. but we are interested in homeostatic processes inside organizations that help to explain why they resist, new practices which we've advertised to them are going to be better or something like that. And so those two things are very much related. All right, so that's kind of where the article ends. So do we have kind of questions about this, about either any of these 4 different archetypes, the basic big picture of how we use this, where we're going from here? Again, where we're going from here is we're actually going to start simulating these and generating our own behaviors over time for complex systems next week. But any questions about this kind of high level perspective this week, these dynamic archetypes and their use? And I will also check the online. No questions there. Okay. All right. So moving forward, so if you haven't already, start reading chapter 3. You got a lot of time to read chapter 3. It is due before lecture D4. So next week is D1 and D2, and then the week after that is D3 and D4. So there's quite a bit of time to start reading chapter 3. But the perusal assignment, the reading exercise, and the reading assessment are all up there and available for you to start using. What I would recommend you do in the short term is to create an Insight Maker account. We've already learned how to use VinSim. We are going to learn how to use more of VinSim, how to draw stock and flow diagrams and simulate them. So more VinSim coming up. But we are also going to pick up this Insight Maker. Insight Maker is a different tool. It has kind of different strengths. It's also for drawing these stock and flow diagrams. Some people like Insight Maker more than VinSim, which is why I teach you both tools. If you end up liking one, you can stick with that one. You don't have to use it, but maybe you'll end up liking the other. So we can have coexistence in this class. That's fine. We are going to start doing a little bit of math in the next one. We're not going to be solving equations so much as we are going to start not just saying there is a causal link between A and B, but we're going to start saying, all right, if A is this particular value, what's B going to look like in the next time step? So it's going to be a little bit of arithmetic to sort of figure out what things are going to look like based on how they are right now. So nothing too complicated, no major calculus or whatever, but we are going to start seeing the numbers and the equations start coming out. Then looking much farther ahead, so 2 weeks down the line, that's when we've got the midterm. So basically the timeline is going to be, we got D1 and D2 next week, D3 and D4 the week after that, and then the Tuesday after that is going to be a midterm review session where we basically go through the greatest hits of the lectures, take your questions, try to answer them, and so on. And then that Thursday, which is like, 3 weeks from now, that's when you're going to have your 2-stage exam. And that first part, the 80% on Respondus with Lockdown Browser, you will do your individual part of that exam. So basically, you'll be given 90 minutes that you can do anytime that day, no lecture that day. So you can do it during the lecture period to take the whole exam. And but you only be able to take it once, and you'll be able to use one sheet of double-sided notes, but otherwise it'll be closed book and closed notes, not collaborative. Then on the Tuesday that follows, you get the exact same exam again, but you get it all day, you get it open book, you get it open notes, and you can collaborate with anyone currently in the class. And so basically, your total score from the exam will be 80% of it will be your individual score, and the other 20% will be your group score. They'll be scored separately and then weighted together for your total midterm score. So that's the way the midterm and the final exam will work. And then after that, we'll go back to lectures. We'll start lecture E1 for the Thursday after that second stage. So as reminders for this week, that's way in the future. For this week, due Sunday, you've got a Muddiest Point as well as that assignment C1 that we just assigned on Tuesday. All right, so I'm going to put up the attendance question, and I'm happy to take questions after that. So let me get that attendance question up here. So I will do the link in the chat, and the question that I will give you here is, what what systems archetype, and remember, I'm just grading this for coherence, not for correctness. So what systems archetype corresponds to the principle of competitive exclusion in ecology, which is the idea that only one species can exist, that a niche can only support one species at a time, that if there's two species, one of them ends up out competing the other one, and you don't get coexistence. So that's the question there. So that's all I've got for you today. So if you have any questions, I'm happy to stick around and take those. I think I do have office hours today, so I'll be starting those up right after the class here, just shifting my Zoom room from this Zoom room to office hours, but I'll stick around in this room for a few minutes. So are there any questions that I can help with? If I don't see you in office hours, then you can I hope you have a nice weekend, and we'll see you Tuesday for Unit D. Great, all right.
Hey,
so
how you doing?
Yep.
Hey, it's escalation, right?
For this one, I'm actually looking for, and I'm happy to give the answer,
Sure.
the success to the successful. So
Yeah.
escalation is two balancing loops. Successful is two reinforcing.
Yep. I knew I was going to mess
All
those
right.
up because they look so similar.
Yeah, well, that's fine. It takes practice. So thanks for being brave enough to ask.
Thank you. Have a nice day.
You too.
Thanks.
Anything else? All right. Bye all.